Hello and welcome back to our channel, Tech Expert Tutorials. In this video, we will show you how to install a MySQL database server, the free Community Edition on Windows, and Workbench, a visual tool for interacting with your database. We will also be performing some initial setup. We'll cover everything you need to know in order to get started with MySQL. This demo will show you how to install using a MSI install file, which automates most of the settings. If you're looking for a more manual or detailed installation instructions with more control over the install settings, see our video on how to install using a .zip file instead. Link can be found below. We will also cover some common issues and how to fix them along the way. These are some of the reasons you would choose MySQL over Microsoft SQL Server or Oracle. For more details on these other two, see our videos on both, link in the description below. The total cost of ownership is lower with MySQL, and there's a lot of support from a large community of developers, including a large open source library. The interface, called the Workbench, is more intuitive, and the database is optimized for smaller queries with smaller amounts of data and fewer connections. High amounts of data or user connections or complex queries would call for an enterprise solution instead. Some of the topics we will be discussing today include how to download and install, solving some common issues while installing, a quick demo for the Workbench and MySQL shell, and we will validate that the database was installed and is working correctly. Okay, let's get started. To begin, we need to download the MSI file for the version of MySQL we will be installing. We are choosing an older, more stable version. We can show you how to upgrade this to a new version later. The installations are similar between versions. What you learn here can be applied to any version that you want to install. Go to the dev.mysql.com/downloads/installer webpage, and you will see the most recent patch of the last two major versions by default. You can also change the operating system here if you want to install on Linux. Click on the Archives tab to see a more complete list of versions and patches that are available. We are selecting product version 5.7.11. There are two options here. We will try the smaller download, which includes an online installation process. When the download finishes, run the installer. Accept the license terms and click Next. We will try the full version, which includes the database server, Workbench IDE, connectors, documentation, samples, and more. Click Next. We see several requirements that failed, so we can either fix them or skip them in the installation later. You can click on each item to get more details on the failure. The first item mentions Visual C++ 2013 is not installed, so we will try and install this and rerun the installation. We find the link to this package here and download. The installer mentions 64-bit, so we select that download. After the file is finished downloading, run the executable. Now we go back to the MySQL installer and restart the .msi file that was downloaded earlier. This time we pick Custom so we can select the products that we will be using in this demo. You will need to drill down to the product by clicking on the plus button and clicking the right arrow to move the item to the right-hand side. Products to be installed. We want to install the server, which contains the database service, and the Workbench to connect to the database and perform maintenance tasks. The versions of these two tools should be compatible as they are packaged into the same installer. When you start using MySQL, you will come across incompatible tool versions. I'll cover this topic in more detail later. Click Next, then click Execute. This also fails. Click the Show Details button to get the specific failure. The log file mentions no valid download found for several products. This error is more likely for older versions. We can either troubleshoot these issues, or we can select a large file download, which includes all the necessary files we will need. We go back and download this 377 megabyte file and run the installer when it is finished downloading. Select Custom again and select the same two tools, then click Next. Once they are ready to install, click on Execute. When the installation is complete, click Next. Now we will configure our database. Click Next. We are setting up a developer machine. The main difference here is how much memory this database will typically use. We want TCP connections and to open a firewall port. You can change the port number if you like. We will leave it set to the default 3306. We select Show Advanced Settings and click Next. We set up a root account with a password here. We can add user accounts here or do this later. We add one user and create the username and password credentials on this form. This account named sysadmin will be used for admin purposes. We enable MySQL authentication, add a password, and click OK. We want the MySQL server to run in the background 24/7, so we will set this up as a Windows service that will start automatically at startup. We use the standard system account for running the service. We give the service a name. Click Next. Here are some advanced options for troubleshooting. We can set up different types of logs for errors, performance issues, and data recovery. Click Next. Now click Execute. The install will run through several configuration steps. It will stop the server if it is currently running, will update firewall settings, make changes to the Windows service, initialize and start the server, create accounts, and update the start menu. Everything ran successfully. If there were any errors, you can view them in the Log tab. Click Finish, then click Next. We usually copy the log in case there are issues later. We want to start up the Workbench to set up the database now that it is installed. Click Finish. There is a default connection already set up for us using the root account. We type in the password and have an option to save this password in a vault so we don't have to type this in each time. We leave this turned off for now. Now we will check our Windows service. We go to the Services application and look for the MySQL 5.7 service. It is running and set to automatic. Looks good. Close this down and go back to the Workbench. This command will show all the databases that are set up by default. This is a beginner video, so we won't be working with these system databases. For testing, first we will create a new database to store some sample data. Run the create statement and then show databases again. Now we can see that the MyDB database was just created. Run the use MyDB command to point your following commands to use this specific database. Now we're going to create a simple table with two columns using int and varchar data types. Run the show tables command after you're finished to see the table we just created. Now we are going to show you how to run commands from the MySQL shell. First, we need to set up a new entry in the path environment variable. Look for the location of the bin directory under the program files MySQL folder. We are adding this to our user account, not globally. Make sure to save this. Now we can open a command prompt and type in MySQL commands directly. First, we want to check the server version. It is 5.7.11 as expected. We start up the MySQL interactive shell with this command. -U is for the username to use, -H is for the hostname, and -P will prompt us for a password. We can run the show database and show tables command like we did from the Workbench. To populate our table with some data, we can use Gemini AI to create an insert statement using this prompt. Copy this SQL statement and run it from the Workbench. We can select the data from our table to verify this worked. Now, we will show several different ways to connect to our database with Python. Any one of these examples will work just fine. At the top are some commands we need to run first, setting up our Python environment using conda and then pip. We prefer to use conda, but to get the correct version for one of these packages, we need to run a pip command as this version is not available in conda. We have found some issues with incompatible versions of Python and SQL Alchemy, so we suggest using these versions for initial setup. We also suggest downloading the necessary package from the CondaForge repository. It has a large selection of packages and versions that are stable and production ready. See our video on Python, Conda, and VS Code for more details on how to set this up. Link in the description below. First, we need to import the necessary packages into our Python script. MySQL is a driver we will use for connecting to the database, similar to using ODBC for Windows. SQL Alchemy is used for connecting to the database. We like using this because it could be used for any type of database and is simple to set up. We use pandas for grabbing the data from the SQL Alchemy engine and displaying the output in a data frame. Our credential variables are set up in the creds.py file. Here are two more that we will need. The first connection example uses this format for the connection string with some separate connection arguments. This is using the MySQL database driver to connect. We create an SQL Alchemy engine, then connect to the server using that engine. Finally, we use pandas to get the result set and put it into a data frame for display. The next example shows how to use TCP to connect. This is where we discovered that we need a different version of SQL Alchemy for our script. Otherwise, we could get an access denied error. In this case, we are using an execute and fetch all function to get the entire result set back to our process. Most of our examples follow this format. This example has all the parameters on the connection string with no extra arguments. Here is an example using the MySQL connector database driver. The rest of the code is similar to above. This example just takes the connection string out of the create engine function as a variable to pass in, and we add an echo command to get more verbose output from the server. You might use this for debugging or tracing. We noticed errors in this example unless we installed this version of Python. For the next example, we install the MySQL client package to avoid errors in this example using the MySQL driver from a client application. We also show that using localhost or this IP address work equally well. Here we are showing what versions of the MySQL client package are available in Conda. Only 3, 1.2 to 1.4 are in Conda Forge. Pip will have more recent package versions. However, some of them may be in alpha or beta mode, so you may find bugs or have issues with them. Now, we will log into the Workbench and back up our databases to disk. If this database was in production, you would want to schedule this backup to run hourly or daily, depending on your needs. For this demo, we will do this manually. Click on Data Export on the left menu pane. You can select the databases you will back up. In our case, we only created one named MyDB. The SYS database contains information used for performance tuning and diagnostics, so you may want to select SYS here. Usually, you will also select the checkboxes for other objects to export below, such as stored procs, events, and triggers. We like to include this create schema option in case we need to build this from scratch, such as moving our database to another server. You can choose to simply dump to one file or to several files within a folder for more flexibility. Here, you can choose dump to data only or structure only or both. We select to include both. You can also change the export or backup location. In production, it is usually better to back up to a network drive in case of a bad local disk or other major problems. We get a warning, which is pretty common, about version incompatibility. This can cause issues in the backup, so it is best to take care of this now. We open Preferences, then Administration, then update the paths to a new version. To find other installed versions, we open a bash shell and run a command called find. This will find the location of the MySQL dump and MySQL applications. We didn't find anything in the first run, so we changed to the root directory and run again. This time we found a few occurrences of the application. If you didn't find other versions, you would have to install those yourself. We can check the versions for these using this command with a -V. One is version 5711, which is the one we want based on the warning. Copy this path and paste it into the first path entry, or you can browse here using the 3 ellipses on the right. You can also do the same for the MySQL tool. The problem is that there were 2 different versions of the same tool, and Workbench was pointing to the wrong one. Now we can start export again. It still fails. We will try to restart the Workbench to get these settings to be applied. So start up the Workbench again and connect. Go to Data Export and make the same selection. Then click on Start Export. So this time it worked. You can see the path to the MySQL dump application is pointing to the correct location now. By the way, this window shows you the commands that were ran. You can also run these commands from a DOS shell prompt instead. Here are the two backup files that were created. We will open them in Notepad. You can see they contain SQL statements. Okay, everything looks okay so far. We can shut down and restart the service from the service application. To upgrade our version to a newer version, we go back to the MSI archive website, then find our new version, which will be 5744. This is the most recent patch for version 5.7. We aren't ready to upgrade to 8 yet, as there are a lot of major changes that may break our applications that are using this database. We download the larger or full version again to avoid the issues we had earlier. Once it finishes downloading, we run the installation. A window will pop up asking to apply an upgrade for product catalog updates. Select yes. When the installer starts, click on Next. If this only shows that we are upgrading Workbench, we will need to click the Add button to include the server upgrade, and then add the MySQLServer to the upgrade list. Expand the items and select the 64-bit version. Then click the right arrow again to add this to the list on the right. Then click Next. There is a warning about a conflict in the data directory path. We want to check this out before continuing. There are files from the current version still in this folder. In our case, we can make a backup of the directory, but since we already made a backup of this data, we can install it into the same folder. This is because we are just upgrading from one minor version to another minor version. But if we were upgrading to version 8 or newer, we would select or create a different directory here, and then run a restore from our backup. Later, we will show you how to restore the database if you selected a different directory here. Click Next and then Execute. Once the installation is complete, click on Next. We will be configuring the new database and selecting the same settings as before. Development computer, TCP/IP, and port, and open firewall for this application. Select Advanced and then click Next. Type in the current password for the root account. This account was carried over to the new version. We configure a new Windows service. We are giving the service a new name. We could leave it the same as before, but we like to know what version we are running, so we change the name here. We want to run this at startup using the system account. Here we can set some permissions. For this demo, we are selecting the Grant Full Access option. Click Next and set up the logging options here. We aren't covering the advanced options today. We'll leave the default settings and click Next. Click Execute and wait for these steps to finish. There is a log tab that can help debug any issues during this upgrade. In our case, there are no issues. The configuration was successful. Workbench version 6.3.6 is currently installed. We restart and try to connect, either using the current connection or creating a new one. Here is how we create a new connection. We choose a name, fill out localhost for a host name, and use the root account. When testing our connection, we get this SSL protocol version mismatch error. The root cause is that our Workbench version does not work well with our database version. The version that does work with 5744 is Workbench 6.3.4. We download this version from this URL, 64-bit MSI file. Then we run the install. We can change the location of this application. We choose the default. Click Next, then click Install. When it's finished, select the Launch Workbench and click Finish. This time, we can connect to our database successfully with no errors. If you selected a new folder for the data directory, you will need to restore the database from the backup we created earlier. Otherwise, this next step is optional. We start up the Workbench in case it was closed earlier. Then we connect to the server. Select Data, Import, Restore. Then we look for the restore point that we want to use. Select the folder and database we want to restore. In this dump folder, we only saved the MyDB database. In another dump folder, we included the sys database in our backup. Go back to the first folder, as we were only going to restore the MyDB database this time. Click on Start Import and wait. This should be quick since there is very little data on our backup. This is taking a while. Something must be wrong. To troubleshoot this, click on Stop and verify the database was not created. Try to run the command in the window in a command prompt in administrator mode. We see an error with the configuration file. This file does not exist. To find the correct config file, open the services application and check the properties of the MySQL service. This is the correct location for the config file. If you want, you can verify this by browsing to this folder and file. In the command line, replace the default file entry with this path and file and rerun the command. Also, this time we put the -u and -p settings in the wrong location of the command. They should come at the end. Remove the database entry as it is also causing errors. The restore should get this name from within the backup files. Run this again. That was very quick and no errors this time. Now we run the restore command for the store procedure we also backed up earlier. This also was quick. So now we go back to the Workbench, refresh our list of schemas, and we can see the MyDB database and store procedure entries now, along with the data. So we found a few bugs in the installation of this version of the Workbench. Luckily, we were able to find some workarounds for now. If you are not going to run this in production or automate this, you would run this from the command line, not the Workbench. We can test some other items in the new version with our SQL statements we used before. Looks like we can see the databases we created earlier. Okay, looks like everything is working fine with no more issues from our install and upgrade. To wrap up, in this video we covered the basics for installing and upgrading, along with solving some common issues that you may have had during the process. Well, that's all we have for today. Stay tuned for more videos on advanced topics with MySQL. As always, comments and suggestions are welcome. See you next time.